So Algebra 8, we are moving on to the last half of our, I shouldn't even say half, last sections of our chapter. Today we're going to be covering section 1.8, solving equations by adding and subtracting. Solving equations, this is some of my favorite stuff. I really enjoy algebra. So you did see some of this in course 2. So it says the first couple examples, we just have to determine whether a number is a solution. So one thing that you have to know is that solution makes the equation true. Okay, so that's kind of a key thing here. It has to make it true. So they want to say, determine which value of x is a solution. Is it going to be x equals 12 or x equals 20? So what I would do is I'd put both of them in. We have 12 minus 7 equals 13, or we have 20 minus 7 equals 13. Well, this one was pretty straightforward. You could see the answer, but let's just do the math. So 12 minus 7 is 5. Does 5 equal 13? No. This is a no. Does 20 minus 7, that gives us 13. Does 13 equal 13? So yes. So which one is a solution? X equals 20 is a solution. Okay, so the next one, it says x plus 8 equals 15. Is it 5 or 23? Well, let's put that in. So 5 plus 8 equals 15. Or 23 plus 8 equals 15. Okay, well, what do you guys notice? What's 5 plus 8? 13. So that one is no. What's 23 plus 8? 31. That one is a no. So our answer here would be neither. Okay. So now solving using addition and subtraction. What I always talk about is making sure you know the two sides of your equation. So we know both sides of my equation. I just draw a line through the equal sign. So we kind of have to think about this as balancing out the equation. We have to try to get the variable by itself. So some of you can do these mentally, but once you get into the harder problems, you need to know how to do the operations to get t by itself or m by itself. So what we're going to do is we have to get rid of this 6. So in order to get rid of it, you can think of it doing the opposite operation, or I like to think of just canceling it out. So if I were to get rid of the 6, I'd have to subtract 6 to get it to 0. Same thing over here. So the 6 minus 6 gives you 0. The positive t just comes down, and then I have 28 minus 6, which is 22. To check, you could do 6 plus 22, does that equal 28? Yes. Okay, on the other side, how would I get rid of this minus 8? Well, 8's being subtracted, so you have to add 8. Minus 8 plus 8 cancels. M equals negative 14 plus 8 is going to give us a negative 6. Okay, letter E. This one is adding a negative 14. So if you do the opposite operation, you would be subtracting a negative 14. Whatever you do to one side, you have to do to the other. But one thing I want you guys to think about, when you subtract a negative, what are you actually doing? You're actually adding. So the way that I think of it is that if I have negative 14 and I want to cancel it and I want to zero it out, I have to add 14. So then those cancel. 15 plus 14 is 29 equals W. Okay, the next one, I have a negative 6, so it's similar to what I had in C, but now I have a negative 6. So if you want to cancel out a negative, you have to make sure that you're adding a positive to that. whatever you do to one side, notice I do the same thing on both sides. J equals -12 plus 6. The negatives win, and by how many? They win by 6. Let me circling my answers here. Okay. Other side, it doesn't matter if we have fractions or decimals, treat them the same way. So this one I have minus 2.5, so to cancel that out, I would have to add 2.25. Make sure your decimal points line up. M equals, make sure they're even. So 5 and 2 is 7. Bring your decimal point down. 4 and 2 is 6. A lot of times if you do these vertically, you can do the problems right in the problem. This one, y minus 1.7, so I need to add 1.7. So I have y equals 6 and 7 is 13. Carry that. It's 2.3. The next one, I have a positive 7.5, so how do I get rid of it? I need to take it away. Whatever I do on one side, I do to the other. Having that line through that equal sign really helps me see where the two sides of my equation are. 6 minus 5 is 1. Put your decimal point. Borrow. 10 minus 7 is 3. One of the last ones here. You have to move the 6 over. It's a minus 6, so you have to add 6. Equals negative 13 plus 6. The negative wins by how many? By 7. Okay. So then you're going to have some application problems. So it says,
Brianna Kleinke, Kira's Sweeney, to the office, please.
This one reads, net force is the sum of all the forces acting on an object, expressed in newtons. It tells you which direction and how quickly the object will move. If two dogs are playing tug of war, so picture this, they're pulling on each other, and the dog on the right pulls with a force of 12, what force is the dog on the left exerting on the rope if the net force is 2? Okay? So the net force is the sum of all forces acting on the object. So we have to add all these forces up. Is expressed in newtons. So it's saying that the net force, so I'm going to kind of write this in words first maybe. So net force equals all forces added. Okay, so two dogs are playing, and the one on the right pulls a force of 12. What is the force of the dog on the left exerting if the rope on the net force is 2? So I'm going to put 2, okay, equals, and then we don't know what this question is, so I'm going to put an x plus 12. So since the forces are acting against each other, this answer is probably not going to be positive. So we would solve it. I'm going to take away the 12. 2 minus 12 gives us a negative 10. So that means that the other dog is pulling of a net force of negative 10. Okay, or not a net force, just a force. So what is the force of the dog on the left? The dog of the left is exerting a force of negative 10n. Okay, so sometimes they're tricky. I like to draw it out in a sentence or word sometimes. That's really helpful to me. That's all for today.